M.Abubakar, and today I'm going to talk about Heisenberg Uncertainty Principle. Before I move to Heisenberg Uncertainty Principle, I would like to talk about uncertainty. Every measurement that we make is accurate up to a certain degree, and whatever we do using the same apparatus, we cannot improve the accuracy of our reading. For example, if I measure something using a meter rule that is accurate to 0.1 centimeter, now all the reading that I take with a meter rule will have an error of 0.1 centimeter. I just cannot measure more accurate than 0.1 centimeter using the meter rule. Actually, there are two forms of uncertainty. One is the absolute uncertainty and other is the percentage uncertainty. The absolute uncertainty in this case will be 0.1 centimeter, but what will be the percentage uncertainty? Percentage uncertainty is absolute uncertainty divided by length multiplied by 100. So if I have this marker is approximately 13.8 centimeter. So the percentage uncertainty will be 0.1 divided by 13.8 multiplied by 100. But what if I have a smaller object such as this dice? In the case of this dice, the length of dice is 1.3 centimeter. So the percentage uncertainty will be 0.1 divided by 1.3 multiplied by 100. So here are some of the stats. In the case of marker, it turns out to be 0.72%, but in the case of dice, it turns out to be 7.7%. So you can see that smaller the length of the object, the smaller will be the denominator and higher will be the percentage uncertainty. If I try to measure width of this bird, there will be even higher percentage uncertainty. So we have made out that the smaller the length, the larger will be the error. The larger will be the error, larger will be the percentage uncertainty. This is the case with the time. If I have a stopwatch and that is accurate to say 0.1 second, and I measure two times. One is, for example, say 3 seconds, and other is, for example, say 100 seconds. So the uncertainty, the percentage uncertainty in the time that is 100 seconds will be less. Momentum is the product of mass and velocity of an object, but here we are only concerned with velocity because the mass of an object is constant. This is an electron, and now the mass of electron is constant. We are only concerned with velocity. This is not a very accurate representation because electrons don't move like this. It moves both like a particle and a wave, so it would move like this. Electron is both a particle and a wave. Now I want to measure the velocity of electron between these two reference points. So if I move an electron between these two reference points, it will take very less time to pass. So the uncertainty in the time will be a lot, and uncertainty in the distance will be a lot because the distance are very close together. So the percentage uncertainty in the distance will be more. So the percentage uncertainty in the measurement of momentum will be a lot. But what about position? I have a good idea about position because I have taken two reference points very close together, and we can say that electron is between here and here. So I have a good idea of where the electron is. Now I want to have a very good information about the momentum of an object. So what I will do, I will take two reference points that are far away. Now the electron will move between them, and it will take somewhat more time to travel between them, so the percentage uncertainty in the time will be less, and it has covered a larger distance, so the percentage uncertainty in the distance will be less, and hence the percentage uncertainty in the velocity will be less. So we have an accurate measurement of the momentum of the electron. But now, since these two reference points are very far away, we have lost track over the position of electron. It can be anywhere from here to here. So Heisenberg Uncertainty Principle says that we cannot measure momentum as well as position of electron or any subatomic particle very accurately. If we try to measure its momentum, we will lose the track of its position, and if we try to measure the position of electron, we will lose the track over its momentum, because if I move them closer, I will have a good knowledge of the position, but the uncertainty in the time and distance will increase. But if I move them far away, there will be less uncertainty in the time and distance, but there will be more uncertainty in the position of object. So that was Heisenberg uncertainty principle. Thanks a lot and have a nice day.